Everybody that's not speaking should be on mute. I don't know if, if Megan just did that or not. Okay, welcome to our webinar on electrifying building heat. We hope to make the case that switching from fracked gas to clean electricity for space and water heating and all the other gas-fired appliances as well will be both necessary and doable to reduce emissions before 2030. We have about an hour of presentations followed by up to 30 minutes of Q&A. And at any time during the presentations, if you have a question or a comment, please add it in the chat. And in order to get it put into the queue, when you put it in the chat, the first thing you type in is stack, S-T-A-C-K, and then just write your question. And Megan Steele, who is our communications coordinator for Sierra Club New Jersey, will collect and sort the questions. And we'll hold the questions to the end because we want to be sure that we hear from all the speakers. Okay. I'm Pat Miller, Climate Reality Leader, member of Sierra Club and Middletown Green Team, and co-founder of Middletown for Clean Energy. My husband Steve and I recently founded a New Jersey-wide group we call the 50 by 30 team. Our goal is for New Jersey to reduce greenhouse gas emissions 50% by 2030 and to zero by 2050. We sent Governor Murphy a letter with our recommendations on how this can be achieved. And it was at the same time as the Empower Coalition had filed a legal petition with the New Jersey DEP demanding the same 2030 goal and a roadmap to get there. Governor Murphy responded to these demands on November 10th with an executive order that targets 50 by 30. We still need the roadmap for how to get there. I'm going to share one slide. Okay. This is a picture of New Jersey's present emissions picture. It's actually from 2018, but that's the last measurement we have. The top three bars account for nearly 90% of New Jersey's emissions. And the top three bars are transportation, residential and commercial heating, which is primarily fracked gas, and electricity generation, which is also mainly gas. New Jersey has policies in place to incentivize a shift toward clean electricity generation and toward clean electric vehicles, but there is no corresponding plan for transitioning from gas to clean electric building heat. That's why we're calling electrification of building heat the third lever for getting to 50 by 30, and that's the third lever of our title. We believe all three levers need to be addressed statewide to meet that goal. Over to you, Steve. And you have to unmute.
Here we go. Got it. Now that I can talk, thank you very much for getting the webinar started. My name is Steve Miller. I'm Sierra Club Climate Chair of the Jersey Shore Group of the New Jersey chapter. I'm going to spend 3 minutes comparing New Jersey to New York State. Now, usually New York State and New Jersey are in lockstep in creating similar programs, but not in building electrification. New York, in fact, is 6 years ahead of New Jersey, and here's why. 6 years ago, New York's created New York State Energy Research and Development Authority, called NYSERDA, with a focus on building electrification. This authority negotiates its own budget and has grown to over 300 employees and is as roughly an extended version of the energy charter of the New Jersey BPU, which employs maybe 20. But the New Jersey DEP is probably more of the implementation portion as well. So there's probably more people in New Jersey. But New York State's population is roughly double that of New Jersey. So they're really far ahead of us in number of people they assign. Now, New Jersey CERTA initially focused on ground source heat pumps. They're at least
New York CERTA.
Sorry, New York CERTA, sorry. On ground source heat pumps, and they're at least 2 times as efficient as air source heat pumps. And although the initial cost of ground source heat pumps is higher, the yearly operating costs are only half, and the amount of energy used is only half. So New York installed 4,000 geothermal heat pumps in businesses and residents right away, and then expanded into air source heat pumps. And New York has created a really fantastic heat pump infrastructure. They provide training for HVAC craft and 50% training financial grants. They provide tools for those firms, satellite mapping that identifies likely buildings for installing heat pumps, and tools which estimate ballpark sales price for each customer, and extensive direct marketing program reaching likely heat pump candidates. And that does auto reply back to HVAC vendors. And they have enormous incentives, like customers installing heat pumps can get $5,000 more back on rebates. And the result is rapidly expanding heat pump installations and corresponding lowering of New York greenhouse gas emissions. In fact, we learned today that New York City, and we just were talking about it before this webinar, has voted to require new buildings that's less than 7 stories to be all electric starting in 2023. That means no gas hookups. Now, New Jersey currently plans to aggressively start building electrification in 2030. But last year's 80 by 50 New Jersey report card strongly recommended that New Jersey first create a detailed roadmap for building electrification, and we continue to await that roadmap. My conclusion, and especially after discussing this with Michael Winka, you're here in a second, that choices very much matter when New Jersey sets policies, because it's the state that determines which levers to pull to motivate residents and businesses. And we hope as well to see an influx of federal funding for climate initiatives from that Build Back Better Act, which we're waiting to get passed. So our first speaker is Mike Winka, a New Jersey lever puller. I have known Mike Winka for several years now. He's currently Executive Director of Sustainable Lawrence. Before retiring from the New Jersey BPU, he was the Energy Advisor to the New Jersey BPU President, and his long New Jersey career taught him levers of control in a whole series of initiatives: solar, offshore wind, energy efficiency, greenhouse gas reduction, energy master plan, microgrid development, and RGGI, Regional Greenhouse Gas Initiative. This work resulted in him receiving 5 national awards. So I applaud you, Mike. And it gives me great pleasure to introduce Mike Winka.
So hi, thank you for that. And just a little correction, NYSERDA has been around for about 40, 50 years.
Really?
And BPU would jump at the chance to be a NYSERDA, just letting you know that. So I'm going to share my screen here. Can you see that?
Yes.
Yes.
I'm going to open that up. Okay. So I know this is a talk about that third lever, and thanks for that introduction. I don't pull levers anymore. I'm retired and unaffiliated, just talk about this stuff. It's great stuff. I'm going to talk about all those levers and how to use all those levers in an integrated manner, because that's going to be the key, not just pulling one lever here or one lever over there. So just to set the stage, this is a map of all the transmission pipelines and wires for electricity, oil, and natural gas. There's enough transmission pipelines and wires to cross the US over 200 times. The energy industry is a $1.2 trillion industry in the US. It's about 6% of US GDP if you counted it as part of the GDP. It's all in all those other factors. And in New Jersey, it's about a $33 billion industry. So most people think when you're talking about an industry that size, that has so much inertia and resistance to change that only government and only industry can affect that change. And yes, governments can do a lot. They can set the policy, they can set the incentives. Industry can go out and build those large clean energy power plants. Governments can permit them, and industries can develop those power plants. But there is a real partnership that has to happen between you as the consumer and user of these levers and government. The more these levers you pick up and use, the more the ability of the government to accelerate those policy levers. And I'll give you an example of how that happens. The Renewable Portfolio Standard, when it came into place in the RPS in 2000, was 0.25%, and it increased to 4% by 2012. BPU in 2003 doubled that, and then in 2006, by regulation, it increased it to 20%. And then the legislature came along and increased it to 50% by 2030. That's because people were using clean, green energy and the RPS, and the ability of the government then to extend that policy. That's how these things happen in partnership. So you have to pick up these levers. I'm not saying that you have to run faster to solve all these greenhouse gas mitigation issues, but it is this partnership and this give and take between government and consumers. And you saw Pat put this up. This is the inventory for greenhouse gas emissions. This is in the DEP 20 by 80 by 50 report. And again, it's an inventory that the DEP does every year. Every state does this the same. Probably every country does this the same. They calculate these things in sectors. And as Pat said, transportation is the largest in New Jersey. Residential commercial heating is second largest, electric generation and industrial. So you can start to develop your policy levers based on these sectors. So that's a good thing in developing policy levers, but it's also not so good because it seems to put things in little silos. It says transportation's over here, residential building sectors over here, electric generation's over here. And this whole energy system that we have today is so integrated, you have to address that in an integrated fashion. Otherwise, you're gonna miss your mark. A little different way to look at that is by looking at it by the fuels that generate those emissions. And you can see here, those same sectors divided out by the energy that's creating those emissions. And for the building sector and electricity, it's mostly natural gas industry thrown in there. And then on the transportation side, it's mostly gasoline. So when you take out those other warming gases and waste, and you do that calculation, you see that it's about 50% natural gas and about 50% gasoline in the fuels that are generating those greenhouse gas emissions from those sectors. And it's just a different way of putting those policies together. You can see that at the household level. The average household in New Jersey has a carbon footprint of about 18 metric tons. And again, those sources of those emissions are about 50% gasoline and about 50% natural gas. And that plays through in the 2019 Energy Master Plan in those strategies to address those sectors. You see transportation, building sectors, renewable, energy efficiency, and modernizing the grid. The integrated energy plan structure is to say, we're going to reduce our emissions from the transportation sector by advancing electric vehicles powered by clean renewable energy. We're going to reduce our emissions from the building sector by electrifying buildings powered by clean renewable energy. We're going to increase renewable energy so we can power the transportation and building sectors. And we're going to decarbonize and modernize the grid by increasing and doubling the electricity and reducing natural gas and gasoline. So it's that integration of those strategies that really is at play here. And you can see this in the summary of the recommendations of the modeling by the Rocky Mountain Institute in the Energy Master Plan. You can get to those goals that are set in the Energy Master Plan of about 100% clean energy and 80% reduction by 2050 with existing technologies. You can do that at a relatively small cost. There is a cost, but that's offset by significant benefits across the board. The existing policies that are in place, those existing policies are in the Clean Energy Act of 2018, will get you to a good start, but you're going to have to advance those policies as you go along to get to the goals in the Energy Master Plan. And that least costs energy system that you build out by 2050 is going to look substantially different than the energy system that you have today. And that's really the resistance that you're seeing. If you could put an end of the pipe technology on for greenhouse gases, you wouldn't have climate deniers. It is that inertia to this big change in the energy system that is driving all of these other issues on the other side. So when you apply those strategies across those sectors, you can see in the DEP Global Warming Response Act, they reduce all of those emissions across those sectors. And another way to look at that is just, again, to look at what's that final energy going to look like. And as we're increasing electricity, we're decreasing pipeline gas and decreasing gasoline significantly. So we're doubling the amount of electricity, and you can see this on this side. We have to increase the amount of clean, renewable electricity that we generate. We go from 75 million megawatt hours to 150 million megawatt hours over 30 years. But today, 50 to 60% of our electricity is generated by natural gas, 40 to 50% by nuclear. And that all depends on the time of the year and the cost over the time of the year, and about 10% by renewable. So if we're increasing strategies like building sector electrification and EVs and increasing the amount of electricity today, we're actually increasing the demand for natural gas unless we're doing that in an integrated fashion with clean, renewable electricity. So if you increase the demand for natural gas, you're just increasing the demand for somebody to come in and put in a pipeline and build another natural gas combined cycle, unless you do this in an integrated fashion. And to look at this in terms of cost, so if you look at the reference case that goes along, to meet those emissions in the Energy Master Plan is only a 0.2% increase over business as usual in energy GDP. That's a relatively small increase, and probably you go to any economist, you're not going to see a 0.2% increase in GDP affect the economy. And the reason for that, and this is a poor slide, but if you look at the right-hand side of this slide, you can see that this orange bar is the cost for that Energy Master Plan of increasing electricity. And this maroon color bar is the avoided cost of not using natural gas, of not using gasoline. And you can see those avoided costs all offset most of all those costs. And then these are the benefits that occur. There's 2 to 3 times the benefits over the cost. And in any cost benefit ratio, when you have a cost benefit greater than 1, that's cost effective, and you're going to implement those strategies. So that's the 2019 Energy Master Plan, getting to 80% reduction by 2050 and 100% clean energy. I'm going to talk a little bit about how you can sort of look at that roadmap to get to 50% reduction by 2030. So to get to 50% reduction, you need to get to 64 million metric tons from where we were at 97 million metric tons. And that, you can just draw a line between those two, 97 and 64 million metric tons. And you can see here, that's the gap between the existing policies. And the existing policies are those that are listed in the Clean Energy Act of 2018. They're listed here. You can read them later. And that's the gap in policy. There was going to be this little gap between those existing policies in 2030, and you were going to have to start to increase your policies anyhow. But if you increase those policies to get to 50% by 2030, that's about an 8 million metric ton increase in reductions that you have to get. So it's not a big stretch to get to 50% by 2030. And here you can see this a little better in terms of the energy uses and the building sectors. You have to go from 97 million metric tons to 64 million metric tons. That's a 33 million metric ton reduction. If you just replace the electricity with clean, renewable electricity, you only get 17 million metric tons. That's half. You have to do something in the transportation sector. You have to have half of the cars on the road, 3.5 million electric vehicles on the road, along with reducing all of that electricity to clean electricity. And those two things aren't going to happen by 2030. And you have to pick up this third lever. These three things have to happen coordinated and integrated across the board. You have to electrify the building sectors, you have to electrify transportation, and you have to move to doing that with clean renewable energy. And you see that in the same structure on the household side. It's just repeated what you see on the larger statewide side. So I know folks are looking for the Build Back Better plan to be passed, and folks are disappointed there's not going to be a federal carbon tax. But there are 24 states with New Jersey that have action plans to say, I'm going to get to 100% clean energy. I'm going to get to 80% by 2050. I'm going to get to carbon neutral. I'm going to get to zero, or I'm going to get to 50% by 2030. 24 states, including New Jersey, are half the states in the country. And they don't depend on a federal carbon tax. They don't depend on a federal clean electricity standard. It would be nice to have. It would help to accelerate this. But there are currently greenhouse gas emission technologies that are currently available that are going to get us to that goal, even without a carbon tax. And the reason I say that is you can look at this slide. It's a little busy slide. I'll go through it in a little bit of detail, but not much. That red bar is the Global Warming Response Act to get to the 2020 goal, to get back to 1990 levels of 124 million metric tons. This gray line is New Jersey's Paris target, and this gold line is the Global Warming Response Act 2050 requirement to get to 80% reduction in greenhouse gases by 2050. These blue bars, these blue lines, that's the existing DEP annual greenhouse gas inventory. And this dotted blue line is that trend of that existing data. You can see we're well below the 2020 requirement. We meet the New Jersey Paris target, and we're below the trend line to get to 80% before 2050, sometime in 2044. And here's the line to get to 50% reduction. If you stay on this trend line, you will get to a 50% reduction by 2034 with the existing strategies in the Energy Master Plan. So what you only have to do is accelerate that by 4 years and accelerate that by 8 million metric tons. And that's doable. Most people will say we got to this trend line because of the market transition from coal to natural gas. And we upscaled nuclear to make it more efficient. And those market forces aren't in play anymore. We've played them out. So where are we going? Those are the same people that didn't see that market transformation, those economic forces happening 15 years ago. And they're the same people that can't see the market forces that are changing us to clean renewable energy and electric vehicles and electric heat pumps. We are on this economic pathway and nothing is going to stop that. And I'll show you why I think that. I'm gonna pass up these two slides just to be able to get to these last couple of slides in some reasonable time. And the good thing about you picking up these levers, they're all incremental. You don't have to do everything all at once. You don't have to, and not everybody has to do everything all at once. Our energy efficiency program only does 0.5% every year and only gets to about 200,000 residents in New Jersey. There's over 400 million households in New Jersey and 400,000 commercial buildings. So we don't have to do everything all at once. The solar program puts on about a couple of 100 megawatts every year. There's 14,000 installations to get to that 5-6% of solar that we currently have. There's over 3 million single family homes, and we've only put solar on 10,000 of them. So we have a big market and a big ability to do, and we can do those things incrementally. Let me just take you through two technologies. To reduce transportation emissions, we're going to move to electric vehicles. Now, you can go buy a Tesla for $60,000, $70,000, but there are plenty of used electric vehicles for under $20,000. And just take, a round trip mileage, because you have to set a mileage. So in this example, it's 40 miles round trip, 5 days a week. The average internal combustion engine will use over 400 gallons of gasoline. That represents 48 million BTUs of energy and cost around $1,400 a year. That same trip by an average electric vehicle only uses 3,500 kilowatt hours, a quarter of the energy, 12 million BTUs, and about a third of the cost. That's what's the economics that are driving this. And because of that energy reduction, you're avoiding almost 3 tons of CO2 in your household carbon footprint. That's good, but remember, if we're increasing electricity, we're increasing natural gas demand. So better is if you can access 3 kW of solar, in this case, either put solar on your roof or buy into a community solar project, you can drive your electric vehicle on your own clean, renewable electricity. Now, that has a 15-year simple payback, and nobody's going to hold a 5-year old car for another 15 years. But just think about this. If you hold that car for 7 years, that revenue of the avoided cost of that gasoline and the solar revenues of the avoided electric cost will actually let you pay for that vehicle in half. Just think about that. You're paying $10,000 for that vehicle based on the revenues that you're making from your own electricity. No car that you buy today is actually going to appreciate like an electric vehicle does. And in that case, you're reducing 4 tons of CO2. You're also reducing gasoline and natural gas and starting to build a storage technology. That's a key. One of the big drawbacks that I hear about electric vehicles is they don't pay road tax. But you could double the road tax on an electric vehicle and still save money. You could quadruple the road tax. We can have public transportation across the base and still have an electric vehicle save money over an internal combustion engine. And again, all of this stuff is incremental. You can do things. You don't have to change out an entire house. You can change it out by zones. You can do a hybrid system. You'll hear about a hybrid system. In this example, we're comparing a high efficiency gas hot water heater to a heat pump hot water heater. Now, the heat pump hot water heater costs twice as much. The operating costs are about the same, but in terms of energy use, it's about 1/3 of the energy use of the gas water heater. And because of that, you're saving about 2 tons or avoiding 2 tons of CO2 emissions on your household carbon footprint. If you tie that together, again, with 1.5 kW of solar on your roof or a community solar project, you actually can power your electric heat pump with your own renewable electricity. And that payback period is 10 years. An electric heat pump is going to last 15 years. Your solar system is going to last for 25 years. So you're going to get 5 years of free renewable electricity to power your hot water. You're going to reduce your natural gas demand. You're going to reduce your heating sector demand, and you're going to be able to store some of your solar electricity in your hot water heater. So that's my presentation. I'm feeling pretty optimistic. I don't know about you, but I'm feeling that we can get to 50% by 2030 with relative ease. So thank you for that, and I'll be around to answer questions if there are any at the end. I'll turn that back over to you, Steve.
Okay, I'll take it. Thank you, Michael. That was very enlightening. Our next speaker is Tom Schuster, who is the Clean Energy Program Director for Sierra Club's Pennsylvania chapter. Tom started with Sierra Club's Beyond Coal campaign in 2012 after having served as the first sustainability officer at the city of Las Cruces, New Mexico. He works to limit pollution from power plants and promote clean energy policies. He'll describe the pains of the Philadelphia Gas Works, a gas-only utility, which is starting to realize it must diversify in order to avoid dying. Okay, it's all yours, Tom. And you're still on mute.
There we go. Sorry, found it.
Great, thank you.
Yeah, when you share your screen, it's hard to see the controls sometimes. Good evening, everyone. Thank you for having me tonight, and thanks for the introduction. Yeah, I'm going to give a little bit of a case study on Philadelphia Gas Works and some of the engagement we've been doing with that utility over at the Pennsylvania chapter. So just a little bit of background information on PGW. It was actually founded quite earlier than most people would probably guess when it comes to a gas utility back in 1836 to deliver something that has a very different meaning today, which is gas lighting. Somewhat ironically, perhaps. Back in 1926, it underwent kind of a major transition in that it was part of the driving force behind getting people to stop using coal to heat their water. And now we're going through a cycle where the utility is facing a need to change again. It's currently the biggest municipal gas utility in the country. And it's owned by the city, operated by the city, but it also has kind of a unique regulatory structure with a charter that requires it to deliver gas as a commodity, and so there would have to be some legal changes to diversify the company. It's got some, I would say, fairly lame plans in place. A lot of its mains are still cast iron mains. They leak quite a lot. It plans to replace them all by 2058, which is really inadequate. And then reduce methane emissions, not all global warming emissions, but just methane emissions by 80% by 2050. In contrast to that, the city has actually passed a Ready for 100 resolution a couple of years ago, one of the largest cities in the country to do so. And that resolution includes community-wide 100% clean energy for all uses. So that includes building heat, that includes transportation, that includes electricity. The utility has not taken any major steps in that direction, except for this diversification study, which I'm going to walk through a little bit of the findings of. And we were hoping when we got involved in a rate case for the utility earlier this year that we could leverage the Ready for 100 resolution and the knowledge that it is city policy to decarbonize, to hopefully negotiate a settlement that starts to recognize that and force a plan by the utility to phase out some of its distribution system, or at least stop expanding it. We didn't get very far with that at all with the Public Utility Commission. We were able to knock down the rate increase somewhat, but they are continuing with their plan to replace all their lines with equipment that is supposed to last 30 plus years, even though we know that in 30 years they will, if we're to address the climate crisis, they won't be using them anymore. So we have our work cut out for us there. This is the inertia that Mike was talking about in his presentation. There's also a major redevelopment happening at the site of the old refinery that closed after a major explosion a couple of years ago. They see that as a major future revenue source for expansion. We and our coalition partners see that as hopefully a major development that can be all electric. Philadelphia, though, is not New York, does not have any kind of ban on new gas hookups, and we will have to work pretty hard to get anything like that in the near future, I think. So moving into the diversification study. So just so that people can kind of see the scope of what's involved here, heating is by far the biggest end use for gas in buildings, almost 3/4 of that use. And I think that's fairly typical for this part of the country. Water heating is another maybe 20% or so. Stoves and clothes drying are smaller wedges, but stoves in particular are something that we think is really important to transition for a couple of reasons. One is there's this sort of like cultural love affair with gas stoves, which is really a product of decades of industry marketing more than anything else. I recently bought an induction stove. I can tell you I replaced my gas stove with it. It's way better. And if anybody is thinking about that, I strongly encourage it. But it also is a source of really scandalous amount of indoor air pollution that has been, there's just been an utter failure of the building codes to regulate indoor air pollution from gas stoves specifically, even though they've recognized that other gas appliances like furnace and water heaters have to be very well vented. So that's kind of just a real big picture view of the end uses. And then one of the important, I think for advocacy purposes, findings of this diversification study is that electrification right now is a no regrets solution for climate. Even given the fact that there's still a lot of coal and gas in the PJM electricity mix, when you are converting the typical house from gas heat to an air source heat pump, you are going to cut your annual greenhouse gas emissions on average in half. Even in the most extreme cases, you're still going to be saving some. And so there's really no reason from a climate perspective we shouldn't start this transition immediately. And as you all know, in New Jersey, with your fairly aggressive, at least compared to Pennsylvania, RPS and plans for offshore wind development, this is getting a better and better, more effective climate tool over time as the amount of clean energy increases, the amount of gas and coal comes offline. And this is a couple of different projectives. And unfortunately, the 80% CES by 2030 is not part of Build Back Better anymore. So we're unlikely probably to see that trajectory, barring some kind of miracle, but we are still on a steady downward trend across the entire grid. So what did the diversification study look at? There were 4 main scenarios, one of which is called decarbonized gas. So this is the idea that, and a lot of gas utilities are enamored with this idea because in theory, you could just replace the product that they pump through their pipelines and into homes with something that has supposedly zero carbon footprint. It could be produced through things like anaerobic digestion. It could be green hydrogen. It could be some sort of synthetic natural gas. They inject that into the pipeline. They serve, they ramp up the percentages of that over time, and they pretty much can continue as the same type of company they are now. We'll get into whether or not that's a fantasy in a bit. Another scenario on the bottom is full electrification of houses. And that is using primarily air source heat pumps in this case, because I think the assumption is, and I shouldn't say just an assumption, I think in most cases, it's generally considered in a dense urban environment like this, that air source heat pumps are going to be more practical than ground source. The exception to that is something called network geothermal systems, and they looked at this a bit, where this is an idea where you can essentially have a network of pipes that operate as a ground source heat pump that are connected to a network of buildings, and that can be individual houses, it can be multifamily, it can be commercial. And the idea is that it's potentially more efficient, that they can kind of share and they can share heat. They can smooth out their heating load sometimes, especially when you're balancing commercial and residential, which tend to be offset. So that was part of the study as well. And then there was this hybrid electrification scheme where everyone adds air source heat pumps, but to deal with the concern that you would have significant spikes in electricity demand during very cold weather, they would maintain the gas infrastructure to act as a backup during those times of peak demand. So those were the four kind of main scenarios they looked at. And actually, they didn't look at network geothermal by itself. They looked at it as kind of a supplement to a hybrid electric or a full electric system. So the first thing they dealt with was kind of projecting the cost of decarbonized gas, and it's not pretty. You can see that according to this slide, the cost ramps up over time, multiplies by a factor of about 10. And that's less the fact that the gas itself is getting more expensive and more the fact that they're using more and more of it over time. There are a few scenarios that are realistic that find that this is easy to come by or easy to produce. And from an environmental perspective, we're very concerned that you would still have the leakage problem of methane, especially if you're using biogas. You'd still have to maintain a very tight system, and it's unlikely that you would be able to, even if you were to reduce the upstream carbon emissions of biogas to zero, which is doubtful. But if you were able to do that, you'd still have to deal with this leakage problem of the product itself. And so this, and you'll be able to see in a couple of slides going forward, this really does kind of kill the possibility of just substituting decarbonized gas and not doing anything else. The study included some cost projections from a consumer perspective. They did these projections for 2030 and 2050. I'm going to show the 2050 ones in a minute. But this looks at the decarbonized scenario, sorry, didn't mean to do that. The decarbonized gas scenario, the electrification scenario, and the hybrid electrification scenario. And then these for reference, these points are basically the business as usual case. It's assuming really no changes to the current system except inflation, which frankly, I won't get quite into this right now, but I don't think that's really a realistic number to project through time. But at any rate, in 2030, we see that from a participant perspective, in other words, those who actually make changes to their home. In this case, in this scenario, fully electrifying. In this scenario, partially electrifying. Those folks do experience lower costs, especially if they're fully electrifying. But we do have this kind of split between participants and non-participants in terms of electrification. And the reason for that is because PGW makes most of its revenue through volumetric gas charges. If people are coming off the system, there are fewer customers, there's less gas being sold, and that means that the remaining customers have to foot more of the bill. And then this issue does compound over time to the point where those non-participant costs in 2050 are really kind of off the charts, because it's really just a handful of people supporting much of the system. And this really highlights the need, if we're going to full electrification, to really have robust programs in place to help low-income customers transition first, because they're not going to very easily be able to put forward the capital costs to make the changes themselves. It's going to be wealthier individuals who do that. And those wealthier individuals will have incentive to do that as gas prices go up. So I think this highlights the importance of equity-focused programs for transition to electrification. The other thing that you can see from the slide, again, by 2050, in an optimistic versus a conservative scenario, it doesn't matter. Either way, you're talking about way higher costs for decarbonized gas than for participants in electrification program. And then this hybrid electrification, I think these are actually underestimates of the cost, because you're talking about having to maintain basically two utility systems. But even according to their assumptions, you're still seeing increased costs relative to the participants in this program. I think we can actually, this non-participant number is actually, it's very high cost, but a very small number of people. And I think that if we're intentional about it, I think we can actually reduce this number of people to near zero. The study also looked at it from PGW's revenue need, and this is just an example. They looked at a number of different scenarios for different business models for the company, including providing heat as a service. They looked at potentially finding different markets for gas, which they mostly shot down. But I won't get into a great amount of detail here, but if you're interested, you can check out the study. I'll include a link at the end. But the bottom line is that it is a challenge from a business perspective for them to essentially have to enter into a new market and create a bunch of new revenue streams in order to stay a viable utility, which they're pretty committed to doing, and not just sort of transitioning out of business. So the study recommended 3 pilots, and that was something that a lot of the advocates were very interested in trying to figure out so that we can work on implementing. We're kind of disappointed, honestly, with 2 of them. The localized decarbonized gas program, we don't have a lot of faith in, although they are at least talking about converting city-generated waste, such as like sewage sludge and things like that, and green waste into biomethane. So it's trying to close some waste loops a little bit, but at the end of the day, I don't think it's really very scalable or particularly cost effective. The weatherization programs for low and moderate income customers with things like on-bill financing, because of the way rates are structured in Pennsylvania, that's actually unlikely to save them much money. And so some of our low-income advocate partners are concerned about whether or not that's going to be an equitable solution, even though I think it's well-intentioned. The one that we're really excited about is that they did see a lot of value in this network geothermal, and they're going to do a more extensive feasibility study on this. They're not moving quite as fast as we would want them to, But the utility, this is one area where PGW actually is excited about a transition because they think that they can use a lot of their existing right-of-way and retain a lot of their employees with similar skill sets because they'd still have to maintain a network of pipes. They'd just be piping, hot or chilled coolant through these pipes instead of gas. So I think that's seen as somewhat of a win-win, but there needs to be a lot more study because it's not really done on a large scale anywhere right now. And just a quick slide on next steps. We think because of the results of this study, because it's not particularly ambitious, we're going to have our work cut out for us from an advocacy perspective. We're in the process of really trying to organize and build up a new coalition called Here for CJ, which is looking to holistically address issues of home repair and weatherization, electrification for low and moderate income homeowners and renters in Philadelphia, and address some longstanding housing inequalities. And also just really ramping up our efforts with the city to put their money where their mouth is with respect to the 100% clean resolution. I will put these links in the chat, which include the study itself and my contact information and the comments that we submitted for background, and I will stop there.
Thank you, Tom. Our next speaker is Dave Ho, and I refer to him as Dr. Energy Saver. He's the owner of Dave Ho's Home Comfort and Energy Experts in Red Bank. He's a certified energy consultant, and I know that he's worked with Nancy Blackwood and probably many, many others. And what he does is makes homes more comfortable, healthier, and energy efficient. So it's all things we know and love. In fact, that's the very first step before installing that heat pump. So with that, take it away, Dave.
Good evening, everybody. I'll just give you a brief history on what we do because I agree with Steve. I started out in the industry in 1987 at a company that did indoor air quality, which led us to HVAC. And then in the late 90s, when the manufacturers came out with environmentally friendly refrigerants, we gravitated towards high efficiency equipment for consumers. And that was to reduce energy consumption, to improve comfort and indoor air quality. So we went out and installed a lot of equipment. And what we realized is 50% of the time it did make it much better. And then the 50% of the time it didn't make a significant difference or even made it worse. So we got educated on building science, which, building science is really just how air moves through a building and heat leaves a building and heat enters a building. So I'm a firm believer in fixing building envelopes, and I'm going to just kind of give you a basic experience what we do when we talk to a customer and what kind of results we can expect in retrofitting or weatherizing existing homes. Most homes, the way they're built, lose 40 to 60% of the air you pay to heat and cool through infiltration and exfiltration. That means air leaking out. We're in the northeast here, we're in a heating climate. So 8 months out of the year, we do need heat. And in a building, there's something called stack effect, which when it's warmer inside the building than outside, all your warm air wants to move up and out the top of your house. And we measure air in what's called a cubic foot of air, about the size of a basketball. So in a house that's losing 40 to 60% of your air you're paying to heat and cool, that's a lot of big chunks of basketballs of air leaving the top of your building. And it's forced to bring in an equal amount lower. So if you're a house on a crawl space or a damp basement, that can add to indoor air quality problems and things of that nature. So when we talk to a consumer, that wants to save energy or improve comfort or indoor air quality, we start with air sealing. And, we work in the New Jersey Clean Energy Program, which is very robust. I knew Mike Winka's name was very familiar. Now I know why. But so when we talk to a consumer, we start with fixing the building envelope before we talk about putting in high efficiency heating or cooling or heat pumps. We focus on the top of the building, which is the A priority. So if you have attics, knee wall cavities, and Cape Cods, you're losing a tremendous amount of heat. Just to give you an idea of what kind of air leakage we're talking about that can cost energy, in an average house, when we get in an attic and we look at not the insulation, we're looking at the air, air barriers. You can look at wire penetrations. You can look at the top of what's called a wall plate or a top plate. And when you add up all these small cracks, gaps, and holes, you're basically operating most houses with the equivalent opening or equivalent leakage area of a window open halfway year round. So if you want to feel what that impact is, go upstairs on your second floor, open a window halfway, and you'll feel what that air leakage actually causes. So we focus on aligning the thermal and the pressure boundary of a house. So the pressure boundary is the air leakage. You seal a house. We can significantly reduce the amount of BTUs it takes to heat and cool a house by doing that. Then we do the thermal boundary. So what we find in, depending on what year the house was built, say a typical 1965 house, which there's a lot of them in New Jersey and the Northeast, that insulation level might be an R11 or an R19. Energy code right now in New Jersey for new houses is R49. Department of Energy recommends R60, and we're in climate zone 4 here in the Northeast. They recommend R60, which is 17 inches of insulation, which is pretty significant insulation. So we always start with the highest priority, which is the top of a building. The second priority, because we're talking a little bit about heat pumps, whether they're air source heat pumps or geothermal heat pumps, are duct systems. Coming from an HVAC industry, when they build houses before they had energy codes, they'd stick ducts anywhere they could out of the way. So we have duct systems that distribute air in attics and in crawl spaces. So if you can imagine, you invest in a high efficiency heat pump to reduce your energy consumption, and you replace just the equipment, but you don't upgrade your duct work, you can be losing up to 40% of that system capacity by trying to distribute warm air in an attic, that gets down to outdoor ambient temperatures. And then in the summertime, when you're cooling, attics can get upwards of 140, 145 degrees in peak summer. And you typically have ductwork in an attic that has a 1/2 inch liner, and you're trying to blow 57-degree air in this distribution system that's in a 140-degree attic. So you are losing an awful lot of BTUs that you're paying to heat and cool, through all these assemblies. And the good news is this is one of the, I'm going to say for consumers, this is one of the easier things to fix. It's one of the lower cost things to fix that has a decent return on investment for consumers. And it has other benefits that we don't talk a lot about. One is comfort. Comfort's very important in houses. And quite honestly, most people that contact my company are seeking to fix comfort issues, cold floors, all kinds of comfort issues. But when we fix the building envelope, we retain more heat. It improves comfort. It improves indoor air quality. A lot of dust in a house is because the house is very leaky, and you have dust in a house that's coming through old fiberglass. So a lot of the particulate you see on TV screens and things of that nature is not stuff you really want to breathe. So by fixing a building envelope, making it more efficient, you improve comfort, you improve indoor air quality, you greatly reduce the cost to own and operate that house. It's more sustainable. When by improving indoor air quality, I can tell you that we've had customers that have respiratory issues and concerns, whether they're infants or seniors perhaps. that were on nebulizers. And this is just one example. We had one customer that was an adult. She was on a nebulizer daily. Her goal was to make the third floor in her house more comfortable. We did that. Simultaneously, the particulate in her house, the dust went away, and she almost eliminated the need for her medications and a nebulizer. So that's a whole nother side of fixing building envelopes. We do see people moving to heat pumps now. Not all electric, because right now, in our climate, if you put in an air source heat pump, you typically need an electric strip backup heat for when it gets cold, which is pretty expensive. Although I know that cold weather, high efficiency heat pumps are coming an awful long way. And in this climate, they can produce 100% of your heating. So I'm really looking forward to that. But what we want to do is we want to weatherize the building shell itself so we can retain much more of that heat all winter, and we can keep out a lot of that heat in the summer. And New Jersey has a lot of contractors like me that work within the New Jersey Clean Energy Program, which has a lot of advantages for consumers. One is we're required to work to what's called BPI, or Building Performance Institute standards, which means that, theoretically means that the contractors are pretty decent, know what they're doing, and we have to test out all these projects. We test in, we test out, so we can quantify results in most cases. And we've seen just pretty awesome results over time by doing simple air sealing and insulation in attics. Some of the comments people make is now my air conditioning in the summer actually cycles on and off, where before, in the summertime when it gets really hot out, the AC would run without cycling. Also, the same is true in the winter. You set your thermostat, it comes up to temperature. And if you have a leaky house, that heat leaks right out and the heat cycles on and off. So when you weatherize the house, you put in the heat and retain it much longer. You reduce the cycle times on your HVAC equipment, which also increases the life of the equipment. So we're kind of, on a granular level, we're where the rubber hits the road. I'm just one of many contractors. There needs to be, quite honestly, to reach these goals, there needs to be many more contractors like myself doing this type of work. The industry is coming along slowly, but we need to keep working on that. For us, on my side of this, the equation, right now, labor's always an issue, and getting guys that are willing to come into this home performance industry and do the grunt work and learn it, that's a challenge. That makes it hard to scale up. But programs like New Jersey has the Clean Energy Program, some of the networks I'm affiliated with, I'm in a network that has probably 100 home performance contractors across the country. So it is coming around. It's a little bit slow, but we always recommend fixing your building envelope in addition to adding solar and high efficiency heat pumps. And that's really all I have at this time.
Thank you, Dave. I wanted to point out that in chat is today's ad from New Jersey Natural Gas. And this sort of ad, maybe if you're in a different utility area, maybe also appearing for your utility. There is a $49 energy audit that does a blower door test for identified air leaks. They use a thermal camera to look around the house to see what is cold. They check insulation, water temperatures, and whatnot. And so what it is a quick evaluation of your house. And then professionals like David can come in and fix them. He knows what to do. So $49 is a good deal, I believe, to get you started. Take advantage of it. I did this 2 years ago. Dave, so go ahead.
Oh, I'm saying absolutely. For people that contact us with a comfort concern or their utilities are high, you cannot accurately diagnose the house without doing some type of decent evaluation. Otherwise, it's typically you get the a Band-Aid solution, which may or may not work, and that's what we want to avoid. So if a consumer is investing and you're in New Jersey natural gas territory, I would definitely consider that, because it's $49. They use the BPI standards and they give you a pretty good evaluation of what's going on in your house. And then when a contractor like myself does come out or somebody else participating, we do our own evaluation and interview the customer as to what their main priorities are. And then we do our own energy modeling as part of that program. So there's big incentives. Right now in New Jersey, the Home Performance with Energy Star program, for somebody to weatherize a house based on energy saving, they can get anywhere from $2,000 to $5,000 cash back. New Jersey Natural Gas offers, up to $15,000 in 0% long-term funding for these projects. So it makes it more doable to fix your house. In a perfect world for us, we would see a customer develop a scope of work to accomplish what we're looking to do for the customer, take advantage of the clean energy program, get them some cash rebates back to offset the cost, and then they can use one of the on-bill repayments. And in a perfect world, the energy savings we produce would offset most, in some cases, all of that payment. So, I'm happy to be participating in that program. It's just renewed for 3 years in my territory. So I would encourage anybody that's considering some of that stuff to work with a contractor in the program to ensure the quality of your work, number one, and take advantage of these utility programs.
So a little more on this story. It's sort of our next step is here. What is a homeowner testimonial of what we've done? I'd like to tell about myself just slightly. So after that $49 audit 2 years ago, I tried to do everything that I heard that were areas for my house. And so I sealed the numerous air leaks and added things like an attic solder cover. But then recently just measured my actual energy consumption over 3 winter days last year. I calculated my actual BTU heat loss. And now I am working with a variety, several heat pump HVAC customers to companies to decide on what heat pump now is suitable for my house to meet my BTU heat loss needs now that I'm sealed up. So that's probably an internet, it would be a webinar at some point in the future. So follow on to come. Pat, it's your show now.
Okay, we have 2 more homeowners who are going to talk about their experiences transitioning to heat pumps and clean electricity. The first is Nancy Facey Blackwood, who is chair of the Red Bank Environmental Commission and Green Team. And she's going to talk about the step-by-step energy efficiency and electrification of her house. And she actually worked with David Ho. So Nancy.
Oh, hi, good evening. Thank you for having me tonight. Yes, I did work with David Ho in our house in Lincroft. And then when we moved to Red Bank, we purchased a 1910 Victorian house. And so we had Dave come in, take a look and say, okay, quickly, what do you think that we can do? And as Dave mentioned before, he said, insulate the top, insulate the bottom, then you go all the way around. So I'm up in my attic right now, and I can just share that we did do that. First, we started with some foil. I don't know if you can see the foil. So that went directly against the rafters. And then 2-inch foam boards right here as an example. And then spray foam, not individual cans, but like a big spray foam thing that went in. And so what we have ended up with what we call Tudor green, and that cut a lot of our heat loss down significantly. Then we did the same thing in the basement, insulating the bottom, same steps. And then later on, we had Dave come in and he did cellulose foam insulation going around the house. So what his team did is they went in from the outside and they actually took the shingles off because we have a balloon frame house, and they blew the cellulose in. And we did notice significant savings, I would say about 1/3. one thing I do need to step back a little bit. When we first moved in order to get get a CO, get the house insured, the house had an in-ground oil tank and knob and tube wiring. You cannot sell your house with either of those. So the previous owner did upgrade the wiring to modern wiring. And then when we moved in, we took out the in-ground oil tank. And my husband, being who he is, likes radiated heat. And he went to an electric boiler against David's advice. And we started seeing our electric bills go up significantly because while it did provide a nice level of heat and it was fossil fuel free, for want of a better word, the bills were high. So then we went to solar panels to help reduce the cost. And the bills were still higher than normal, but it's still very efficient. So at the next stage is when we went to heat pumps to completely electrify the house. And we worked with an installer that had some experience with heat pumps, and they put in what they call as a hybrid system. So basically what it is to them as a hybrid system is ducted insulation on the first floor. I mean, sorry, not insulation, ducted heat pumps with a heat pump hot water heater. And that went from the basement up to the first floor. And then on the second floor in the bedrooms, they did the individual units. So that's basically what we did now. And one of the first things that we noticed is that we ended up with a huge credit on our electric bill from New Jersey JCP&L. And then they changed the meter in September, and we didn't get a bill for a number of months. We also had some construction, but we did finally get a bill yesterday. And it turns out that our bill, our electric bill, averaged $70, which is a significant savings for us. Also, one thing I do want to mention is that we do have an electric car as well. So this is our complete fuel, just how our household actually runs. The only thing we have left in our house that is run on fossil fuels is the dryer. And when that goes, we'll replace it with an electric dryer. So that's all I have, unless you want more details.
Great.
Do you
Yep.
have an electrical supplier that uses renewable electricity?
Yes, of course, yes. We use Clean Choice Energy. Thank you for reminding me. So whenever we do go on grid, we were buying from Clean Choice Energy, and we still are. Yes.
Great, thank you. We'll also hear from Greg Foreman, who is the Conservation Chair for the New Jersey Sierra Club. And he's going to speak about his experience with the heat pump.
Well, thank you. I guess to get some of the formalities out, I too use clean choice, so I get my renewable electricity. And so basically what I start out with is I have a home in Sussex County. We get pretty cold, or in Hamburg, up in the mountains. And I have an oil furnace to begin with. And what I did is I contacted AJ Perry, who's out of Tinton Falls. It's a reputable AVAC contractor. They sent out I want to call him a salesman, but I don't think he was a salesman, because what he did is he asked some key questions about the installation, my home, and I informed him that when I retired about 10 years ago, less than 10 years ago, I took some money and we replaced the windows, we replaced the doors, put new siding on the house, as well as insulated the walls, because this was an old 1950s. I had long time ago put extra insulation in the attic, and that cost my bills down a little bit. Anyways, what he did is he sized an air heat pump There was a carrier. The efficiency rating was about a half, 500 something, so I couldn't qualify for the rebates. But I have a small house anyway. And they ran 2 holes through my wall. One was for the electric, the other for the fluids that go in. They put coils in the air blower. Didn't have to do anything to my furnace, and they installed a Nest and then wired me up. The Nest is kind of interesting because it controls the both the oil burner as well as the heat pump. And when it's set, when it goes below a certain temperature, it'll shut the heat pump up and turn the oil heat up. In a week like this, when the weather is above freezing during the day, it's nice to hear the fan come on and not hear the oil burner kicking on. You know, the home's kept pretty comfortable. I have it set at 63. I didn't have central air before. I had window air conditioners in the summer, but I bought this in August, and the air conditioning I set at 76. I was comfortable. And the electric bill went up, but it's not too far up. And I haven't, I still have a half a tank of fuel oil, and I filled it up last March. So I haven't used much oil this season yet. But like I say, I'm very, very happy with the whole thing. I think based on my calculations, I should probably cut my heating bill at least 25%, maybe closer to 50%, depending on how much the oil prices go up. Anyways, I'm very happy with it.
Great. Thank you so much, Greg. I think we're ready for the Q&A. We are running kind of late, so we're not going to have much time for that. But Megan, do you have any questions queued up?
Yeah, sorry, I have some background noise, but I have the questions here. So Peter had 2 questions. I don't know, Peter, if you want to come off mute and ask your questions to the group.
Sure. Actually, I'm interested, a couple of questions about heat pumps. The first one that was mentioned was a ground source heat pump. So I wondered whether the fact that I have radon under my house and I have a radon mitigation system would keep me from safely using a ground source heat pump, or whether then somebody mentioned an air source heat pump, whether that's the better choice and whether that works as well and works to as low a temperature as a ground source heat pump.
Can one of our speakers answer that?
I have a thought on it. A ground source heat pump, geothermal heat pump, those are closed loops. So that really, and I would talk to the installers, but to my knowledge, the loops that go either horizontal or vertical, that's going to be where it comes into your house to hook up to your equipment and your coil. That's all sealed. So that should not be a source of, that should not increase any leakage from any ground contaminants coming in. But you'd have to talk to an installer, but I think you should be fine using ground source if you can with radon, because you've got a great radon mitigation system, but the loops are not going to be an opening from the ground into your home, if that helps.
And are the ground source ones better in some way than the air source ones?
Yes, they are significantly more efficient. And as they mentioned initially, they're more expensive to put in, but you're extracting heat from the earth, and which remains at a constant temperature. So all you need is these things have small compressors or variable capacity compressors that do this. So they're extremely efficient, more so than an air source.
Right. So to add on to David's point, your ground temperature 3 feet below the surface, maybe a little deeper in Sussex, is about 55 degrees. So to get to heat, you only have to, increase that from 55 degrees to whatever, 80, and then inside your house to whatever temperature, 65. And then air conditioning, you're, at the temperature that you're going to feel comfortable at air conditioning. And it's a lot more, so if you walk into a house with geothermal, you feel a lot more comfortable heating and cooling. It's just a more comfortable feeling than, a furnace or a baseboard heating system. So it's a more natural heat.
So they don't have to drill down very far. It's only a few feet.
Well, vertically, if it's vertical, they're going down 300 feet.
Oh,
Depending on-
300 feet.
Well, yeah. And if it's horizontal, it's not that deep. It's about the depth of I have a well in my house. My well goes down 200 and plus feet. So it's about the same distance as your, drinking water well.
That's probably the most significant cost then of
Yeah,
installing.
that's the cost. The SEERs of these are, David can probably know better, but they're 20 plus, right? In terms of seasonal energy efficiency ratings. They're probably the most efficient systems out there for heating and air conditioning.
Yeah, I would agree with that, Mike.
Okay, thank you.
Steve, there are a number of questions about the third-party electric.
Yeah, I've been tracking third-party supplier prices for about 5 years. And in fact, using the lowest price supplier, I maintain a website of my findings. And I put the website URL in chat. So if you wanted to know what the choices are and what their prices are, take a look. Typically, I've paid 10% less than JCP&L prices. However, in the last 3 months, there was a dramatic price increase of renewable. And I think that's true. I hope it's temporary. I expect it is. And so I would propose that if you wanted to go with renewable, you could use this table that I maintain, but wait a few months till the prices come down and then buy a 2 or 3 year contract. But I wanted to point out that the first page of my electric.smiller.org shows that the instead of going to a third party supplier, it's probably better to use your own electric, like solar on your rooftop.
Right.
Or buy into community solar on your own, and at or buy a third-party supplier who is local. If not local, then maybe PJM territory. So those are all considerations. I'd talk about that in that website.
Yeah. If you put solar on your roof, given the avoided costs that you have and the capital cost now is, you probably can get it for $2 a watt, $2,000 kW installed. The typical house is about 7 kW. You're going to get a return on your investment of about 10%. Simple payback period is somewhere between 7 to 10 years. And the system lasts, 25 years, although the efficiency decreases. Yeah, and you're talking about panels with efficiencies of about 20% now. So it's, pretty cost effective at this point in time, even with the lower, what are they called, SUSI SRECs now that are out there at $90 a megawatt hour. So pretty cost effective.
Okay, and then I think Linda had a question. Linda M, do you need a humidifier with a heat pump system?
Well, it's not conditioned air. Well, so, anytime you're adding heat into the system, you're driving off some moisture in your house. I'm not I'm not the expert on the humidity factor. Maybe David knows, but you're putting heat into a system in your house, so you're driving off the moisture.
I'm sorry,
Anyway,
could you repeat the question?
Do
It's
you-
whether you, go ahead.
Do you need a humidifier with a heat pump system?
I would say probably not, if the house is well air sealed. If you have a house with forced air can be dry, that's the theory, but a lot of sources of dryness in the winter are excessive air leakage. So I would say you could get a humidifier. They're not a huge investment, but you have to be very judicial with how you set it, because they can over humidify easily and cause moisture or roof problems.
Right.
So if the house is well air sealed and insulated, typically people cooking, bathing, plants, pets are enough to keep you comfortable in the winter, typically.
And then Kathleen had a question. Does anyone have any advice on how to get a condominium to consider solar panels? And also Linda and Kathleen both asked recommendations for solar panel companies.
Well, so maybe Steve has some recommendations, but there is a website that was started by DOE. It's called Sage. They sort of review the contractor's history. So you have to be vetted to get onto the system. And typically you put your zip code and you get 3 or 4 of these vetted contractors that come out to you. On the condominium side, there is a law on the books that, you know, condominiums can't refuse, but they can manage that system. I can go back and look and see if I can find the law and where it is, but it's a hard one to get across in a condominium association. So,
Yeah, Sage is recommended by green teams, by the way. Of one of the green team projects is solarification for cities, and Sage is recommended to get a very quick quote from a number of companies at the same time, and you can compare the quotes.
And I had actually written down the wrong question for Linda, so now I have the correct one. It is, would ground heat pumps be problematic if you are near a stream?
That should be irrelevant.
yeah.
Because you can have the geothermal loops that either go vertical or horizontal. They also Cornell University has huge geothermal loops in their lake. So they don't contaminate water or anything like that. So that should be non-problematic.
Right.
And that is all the questions that we had in the chat.
Okay.
Steve, I think you should
I think
quickly.
let people have some homework. What I'd like to do is draw your attention to the last link that's in chat. And I'd like to talk about it and show you what it is. I'm going to click on it myself. And I'm going to share screen. So this is an action item that people can take with them and complete it after the end of our meeting. Basically, to meet U.S. commitments to the Paris Agreement, we need aggressive action by both federal and state governments to boost us to 50% by 2030 and net zero by 2050. And we know the Build Back Better Act passed the House, and now it's being considered by the Senate. It really has a lot of money, $500 billion dedicated to climate investments to help meet these goals. But we have polluters like Exxon attempting to water down the bold climate choice policies in this, and they're fighting for more subsidies. So we've got to push back against harmful and dangerous amendments to the Build Back Better Act. So the next several minutes, I'd like you to do an exercise. Send your senators, that's Menendez and Cory Booker, a letter to keep the bill strong and fend off attacks. And pass that Build Back Better Act now. I hope it doesn't get delayed till March, but we'll see what happens. We want that planned $500 billion to continue to be in that bill so we can combat climate change. And so the way to do it is you just enter into that website your name. Normally this self-populates, it's not. So I'm really doing it just like you should be doing, filling out the form. If you go to that link, fill out the form. Okay, and then hit continue. Must enter a value in the first name field. Oh, I did. I hope that's there. It did work. And the final thing you need to do is to fill out a title for the senators. They need a title to reply back to you. And so you're going to be getting a message back from them once you send this letter. And I encourage you to personalize it with what you want to say here. And for instance, for me, we are in a war here. And we need to reduce our, you can write whatever you want to. This is what I'm saying in my personalization. And these personalized letters have more impact than just sending the letter as it is. So do this. Okay. There we go. Something like that, whatever you want to say. And then click send the message. It's very simple to do it. I just completed it in probably 3 minutes and I'm done. You should do the same. Personalize it, send it off, and they'll send you back a nice letter. There they are. Thank you for taking action. I just sent the letter to Cory Booker and Bob Menendez. And that'll be the action item for your homework for tonight. Is there any last words from anybody? I'm going to turn off my share.
I put in a question later. They used to have, they're like solar panels, only they were a lot smaller. They were narrow and came down, but they carried fluid through them, and they were used for hot water for showers and stuff, not for, as far as I know, not for heating the house, because there wasn't very much of that stuff. Is that cheaper than solar panels, or is solar panels become so efficient that they're cheaper now?
David, when I lived in New Mexico, those were all over the place. It depends on the climate. They tend to work better where it's sunnier. I think around here, I think that with the efficiency increases in photovoltaics, there's not much reason, I think, to put in like a solar hot water thermal system. Mike, I don't know if you have any different opinion on that, but I think it is pretty climate dependent.
Yeah, so as David Ho said, we're in a heating climate. So putting in something, the solar hot water heater, we're good in the summertime, but you lose that in the wintertime. And again, putting solar panels on with your heat pump, you can put 7 kW of solar on your roof and run your heat pump, air conditioning and heating for an average home. And again, with some backup hybrid system. So it's a lot more efficient. I mean, as I said, the cost, you can install a solar panel system for $2 a watt, which is we're talking about 6 cents a kilowatt hour installed. So it's pretty pretty cheap at this point in time. And at this point in time, those incentives are going to be getting less and less because they're more cost effective. If you're even thinking about putting in solar, now's the time to do that because those incentives are only going to continue to decrease over time. So, as the price comes down, which is what should actually happen. So,
Thank you.
This is Nancy. There was just one thing I did want to share is that I looked into how our heat pumps are good, and they're good. They will function according to the manual up to negative 5 degrees Fahrenheit. So we'll let you know this winter how it goes.
I hope we don't reach -5 degrees.
That's pretty pessimistic.
We don't usually get that hot. I mean, that cold. So, you know.
So, good thing about heat pumps, regardless of the temperature, it's always pulling out heat as long as that condensing fluid can extract the heat. So it's pretty, and they're getting better and better every year. So.
Right.
Yeah, I heated a house for 15 years with ductless heat pumps, and during nor'easters, I got my infrared camera out, and it was maybe in the teens outside and windy and snowing, and I was still getting, 105, 108 degree supply air, and they weren't rated for that, but they were actually doing better than they were rated.
Cool.
They've come a long way since then.
Say, I've got a question. This is Marvin Miller. Can you all hear me?
Yes,
Yep.
we can.
I unmuted. I live in
We're related.
Minnesota. Okay, I live in Minnesota. Of course, it's very, very cold here in the winter. Actually, it's a very long winter. And I hear you talk about, heating seasons in New Jersey, which in my opinion are mild compared to Minnesota. So is
Not from
there
where I
any,
sit.
yeah, is there any cost-effective method I can use in Minnesota to heat my house? Which of course, today I heat with gas.
Well, you want to talk to the folks at what's the group up there in Vermont? Tom, you may know, Sue Coakley used to run the group. They do run
The
a program,
Vermont VEIC,
Energy-
Vermont
the
Energy,
Energy Industries Association or something
yeah,
along that
something
line.
like that.
So it's Sue Coakley's group. She may be retired by this point in time, but they run a program on cold weather heat pumps, and they're sort of the voice that's out there looking at cold weather heat pumps. So Vermont probably has about the same weather conditions that you have out there in Minnesota, maybe a little more windy where you are. But if you go to their website and look at what they're doing in cold weather heat pumps, you might be able to find some ideas for what you can do in Minnesota.
Okay, in contrary to Minnesota, I do have a place in Arkansas. And about 4 or 5 years ago, I installed a hybrid wall heater, which is actually an air conditioner as well. And I can say that it's a Fujitsu system, and it turns out to be very efficient. I typically heat in the winter there and cool in the summer. And my typical heating and cooling electrical bill, actually it's no more than $50 a month. I've seen it jump up to $70 when we're there full time in the winter, but it maintains a pretty good temperature.
Yeah. Yeah. And I remember the name. The name of the group is the Northeast Energy Efficiency Partnership up there. And Tom put the name of the Rocky Mountain Institute also out there in Colorado. Does a lot of work on cold weather heat pumps. Yeah, they're pretty efficient. As long as you can operate without that backup heat, once that electric baseboard heater kicks in, that's where your cost goes out the window. But that only happens when, as Nancy said, if you're getting to 5 below zero, then it's not going to move that heat around. It gets less efficient. It's heat pumps 300%, got a coefficient of performance of 300% efficiency. If you calculate that in efficiency, it gets less as it gets colder, but it's still moving heat around even at, -5 degrees. So they're pretty unique pieces of equipment. So
Maine today announced they reached their 100,000 heat pumps installed in Maine.
Yeah.
And they were looking for 60,000 more this coming year.
yeah.
So apparently they're effective.
Right, if they could do
Maine.
it in Maine. And Maine, they heat a lot with oil and they don't have natural gas. You just can't put natural gas in the bedrock that's up there. So, they have to go heat pumps and electric heating for their heating.
I've got a question on when you say heat pumps, are you referring to the kind that you dig a hole in the ground, put pipes down there and you circulate?
Well, that's one type of heat pump. That's a ground source heat pump or a geothermal system. And then there's an air source heat pump. There's different types of air source. There's mini splits, ductless mini splits, and then
mini split. I have a mini
Right.
split. That's what I have in Arkansas.
Right. So those work pretty well. And then you can get an entire heat pump system or a hybrid system that runs with ducts. So,
And there's a comment in the chat that Chris put in, saying, I have put in 1,000 air source heat pumps and VRF systems since 2005. The good ones are rated down to -13 Fahrenheit, and they will operate down to -18 Fahrenheit. I do remember, Marv, that you got down to -40 in the last year or two.
Oh, in Minnesota. Oh, yes. It gets there. And then what do? You keep the wood burner going, keep throwing wood into the burner.
Well, that's one thing. You need a backup.
Mhm.
We probably should thank all the speakers and all the audience members for your participation. And this was just a really exciting time. I'm so happy and thankful that everybody came and contributed.
So thank you for holding
Thank
this. This is very informative.
thank you. So
you.
anytime.
Night,
Great,
everyone.
great
Thank you,
presenting.
everyone.
Have a
Yeah,
good
Thank
Take
you for
care.
joining us.
Thank you.
Yep.
Yeah.
Bye-bye.
Yeah, thank you, guys.
Everyone. It was great.